I'm a student at Cascadia Community College in Bothell, Washington. I'm currently studying within the Network Infrastructure Technologies program, and today I'd like to discuss a little bit about the new feature available with IPv6 called Stateless Address Auto-Configuration. Before we actually dive into that, I'd like to give a brief introduction to IPv6 addressing. An IPv6 address is 128 bits long, which means there's a huge number of addresses available. It's actually 2 to the 128th power. If you look at an example of an IP address, you'll notice that it's divided into 8 hexstats. Each hexstat is 16 bits long, and each of the characters within the hexstat is called a nibble, and that would be 4 bits. A common configuration for a network would be that the first 48 bits would be the network prefix. The next 16 would be where you can subnet the network prefix, and then the last 64 bits would be the host IP part of it. So if we continue, the stateless address configuration is a new, fairly powerful feature with IPv6. It allows the local router to provide IP information to the host. So it's somewhat of a replacement for DHCP or for having to manually configure the host with an IP address. So the router will provide the host with a network prefix, which is globally routable, and also provide the host with a default gateway. One requirement to actually use stateless address auto configuration is that the network address portion of the address must be 64 bits, and the host portion of the address must also be 64 bits. If you notice here, there's 4 simple steps to set up the stateless auto configuration on the router. You first enable IPv6 unicast routing. This allows the router to route IPv6 packets and to forward them. You then configure an interface on the router to use the stateless address auto configuration. You configure an IPv6 address on the interface, and you turn on the interface. Now if we take a look at packet tracer, you see this very simple topology here. We have a host and a switch, and we have no router at this time. So let's first take a look at the host's IP configuration. You'll notice that there is no IP information in here other than a link local address. A link local address is used only for the local LAN. It's not routable through the network. And a couple things about the link local address: it always begins with FE80, and then it creates the host portion of the address by using the MAC address of the host. Since the MAC address is only 48 bits, it embeds within the address FFFE. It also flips the 7th bit here, so if it was 0, it would become 1. If it was 1, it would become 0. It embeds FFFE because the host portion of the address must be 64 bits. So if we add a router to our diagram here, and we connect it to the switch, will be our first step. And we'll connect it to the gigabit Ethernet port. We can then go into the router, and we will add the information needed to configure stateless auto configuration by simply going into the command line. You then go into privileged mode, and then configuration terminal mode. And the first step is to enable unicast routing by simply typing in IPv6 unicast routing. You then go into the interface you want to configure with stateless auto configuration. So we'll go into G0/0. We will then turn on stateless auto configuration. Once we've done that, we will then assign an IP address to the interface. We'll just make up an address here. And then we'll tell it that the remaining part of it is all zeros, and we'll tell it that it's a 64-bit network range. Once we've done that, we then can turn the interface on. And once the interface communicates with the switch, we'll see that it will begin to advertise the ability of giving the information to the host as far as IP information is concerned. Once that light turns to green, we'll go back into the PC and we will see that indeed it has done that. So we'll close out of here, we'll go back into the PC, and if we switch to auto config, you'll notice that we did get an IP address, or we got the network prefix information from the router, we got the gateway information from the router, the host configured the host portion of the address using the same concept of using its MAC address and adding FFFE, which is called EUI-64. The gateway, as you'll notice, is actually the link local address of the interface on the router. That's what it provides for the gateway. So I hope that this was helpful to you. It's a very simple presentation of how a router can provide the IP information to the host. Thank you very much.